Hi everyone, I wanted to help you out with theoretical probability and I'm using MobyMax to help me with this. So today we're doing theoretical probability. Theoretical probability involves the number of desired outcomes compared to the number of possible outcomes. So we're going to look at how to determine possible outcomes, then desired outcomes, and then write it as probability. So let's talk about possible outcomes. Possible outcomes has to do with an event that is happening in all of the outcomes that are possible. So we have four events right here. One is spinning a seven-sided spinner. One is pulling a name out of a hat. One is selecting a raffle ticket, and one is rolling a die. So in order for us to determine the possible outcomes, we have to know how many outcomes there are in the event. So a seven-sided spinner would mean that there are seven numbers on the spinner. So I have seven possible outcomes. Pulling a name out of a hat depends on how many names are in that hat. There are 23 names in that hat, so there are 23 possible outcomes. Selecting a raffle ticket, well, it all depends on how many are sold. 97 are sold, so there would be 97 possible outcomes. And then rolling a single six-sided die, six sides on the die, six possible outcomes. So a number cube with the numbers 1 through 6 is rolled. How many total number of outcomes are there? Well, if I'm rolling a number cube with the numbers 1 through 6, that means there's 1, 2, 3, 4, 5, and 6 on the number cube. So there are 6 total number of outcomes. Now, let's talk about desired outcomes. We need to know the possible outcomes for each situation, but we also want to know the desired outcomes in order to write probability. So the first thing I look for is the total number of outcomes or possible outcomes, and then I look for the number of desired outcomes or what I am trying to see what could happen, what I want to happen. So spinning a seven-sided spinner and the arrow landing on the number 5. Well, there's 7 sections on the spinner, so I am going to put 7 there. I want it to land on the number 5, so there is one number 5, so my desired outcome is 1 because there's only one number 5. In this case, rolling a six-sided die and having an even number face up when I roll it, well, the die has 6 sides, so there's 6 possible outcomes. Why are there 3 desired outcomes? Well, the numbers on a die are 1, 2, 3, 4, 5, and 6. I want an even number. 1 isn't even. 2 is. 3 isn't. 4 is. 5 isn't. 6 is. So there are 2, 4, and 6, which are all even numbers. There are 3 desired outcomes. So when trying to find the probability of rolling an even number on a number cubes, how many desired outcomes are there? Well, I want to roll an even number. The numbers on a die, once again, are 1, 2, 3, 4, 5, and 6. How many of those are even? 2, 4, and 6. There are 3 desired outcomes. All right, so now let's determine the theoretical probability. So I want to know the theoretical probability, which is desired to total outcomes or desired to possible outcomes. I want to roll the number 2 on a six-sided die. Well, automatically I know that there are 6 sides on that die. So there are 6 possible outcomes. How many number 2s are on that die? Well, there is 1. So my theoretical probability, there is 1, 2, so 1 and 6 total to 6. Now, selecting a yellow marble from the collections shown. Well, I need to know total 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the possible number of outcomes. And I need to know how many yellows there are. 1, 2, 3, 4, 5 yellows. So my theoretical probability is 5 over 9, or 5/9, or 5 to 9 if I read it as a ratio. So now let's go a little bit further and let's determine the probability when I am, and I'm going to put it in a percent form. So there are 3 different situations and I want to determine probability. So here we go, selecting a red marble at random from the collection shown. So I'm going to write on this for a minute. Okay, so how many red marbles are there? Excuse my horrible writing on this computer screen. There are 3 red. That's my desire. Excuse me. Let's erase that. There are not 3 red. How many red are there? There are 2 red. That's my desired outcome. Now, probability is desired to possible. How many possible outcomes are there? All of them combined? Well, there is 5. Now, if you notice, all of our probabilities are written as, or our answers are as percentages. Well, 2/5, I need to make that a percentage. So to make it a percentage, I have to get it to something over 100, correct? So to turn a fraction into a percentage, I put it as something over 100, and then I cross multiply, divide by the one that's remaining, 5. 2 times 100 is 200, divided by 5 would be 40. So the theoretical probability that a red marble selected at random would be 40%. Now, selecting a red chess piece at random from the collection shown. First, I've got to determine how many red are there, which there they are right there, 2. And then I have to determine how many possible outcomes there are. Well, there's not 1, 2, 3, 4, 5, 6. There's not 6 possible outcomes because that's only the ones that aren't red. I've got to add those 2 in, which would be 8. And once again, I'm trying to make a percentage, so I want to make this to where it equals 100. So 2 times 100 is 200, divided by 8 would be 25. And I'm out of room here, but 25. So my correct answer to this one is 25. And now let's look down at this one. We already know it's right because it told me it was right, but let's just determine how I would do it. Drawing a number 7 out of a lottery wheel containing numbers 1 through 50. Well, how many numbers are in the lottery wheel? There are 50. So my possible outcomes are 50. And how many number 7s are in there? Only 1. And this one is real easy to turn into 100 because I can just double it. And that's how I get my 2%. So that is how you determine theoretical probability. Remember, it's all about the total number of outcomes and the desired number of outcomes, and it's desired over total.